Okay. Hey, how'd that homework go? What page was it? 7980. Okay. Coming out to you is old homework. Grab yours, pass on the rest. And then let's take a look at page 7980 if you don't mind. What questions do you have on 79 and 80? 7980, what questions? Questions. Yeah. Number 12? You got it. All right, problem number 12.
Oliver, you just skipped all of these people. Did it? Don't call him stupid.
Oh, the Sawyer passed.
Hey,
Okay, so that's what they give us originally. So let's go through and answer the question. So I've told you that the domain for all these will just be negative to positive infinity. Is that okay? Okay, so I think everyone's set on that. And then let's find the range. Okay, so the range is always a tough one to think about. So the range deals with a y value, yes? Domain deals with a y value, yes? Does that make sense? Because domain and range, D and R are alphabetical, X and Y are alphabetical. Okay, so if I'm going to ride up this elevator, where do I start seeing my graph? Right about there? And then I'll see it forever? So range is the y value. So what does my range have to be on this one? Where do you start seeing it in the y direction? What's my vertex? What's my vertex? What's my vertex?
4.
0, 4, right? What's the y value of my vertex? What's the y value of my vertex? 4. Range deals with y. So this range goes from 4 to infinity. Okay. Letter C says we want the max or the min. Okay, so let's think about this. Is my vertex opening upward?
Yes.
So is my vertex the highest point or the lowest point? The lowest point. So what is my vertex in this, a max or a min? It's a min, and the minimum value is 4. Okay, then you're talking about the max and min. It goes in the y direction as well. Okay, letter D. The intervals where it is decreasing. Ooh, decreasing. Okay, so remember this. If it's decreasing, if I was on the side that was decreasing, if I picked 2 of those points and I found the slope using my slope equation, which is like so last year, that would give me a negative slope. So where would I have a negative slope? Negative infinity to 0 is exactly right. It's right here. This region here is a negative sloped region. Okay? And it goes up to 0. And the reason I use a rounded bracket is because right at 0, it's actually a horizontal line. Any roots? Does it cross the x-axis at all?
There is no roots.
So there's no roots. So what do we call it? What kind of no roots is it?
Complex.
Complex. Awesome. That's it. They are complex roots. Okay, if it will never cross it, they have to be complex solutions or complex roots. Okay, that means that if we tried to solve it, our answer would be the square root of a negative number. Okay? And then the coordinates of the vertex. Oh, we got that. That's my vertex. Cool. The equation of the axis of symmetry. So ALS is x is equal to 0. So is the x component. And then find the y-intercept. What's the y-intercept on this particular one?
0, 4.
0, 4. Yeah, so the y-intercept can indeed be my vertex as well. So it is in this case. And that's how we walk through that problem. Is that okay, Sophie? No curls today? What other questions might you have come across on last night's homework? Yeah. 3? You got it.
Wait, don't you have to write the equation?
Did I miss it? For the graph, identify the domain, range, max, intervals, decreasing roots, coordinates of the vertex. The equation of axis of symmetry. That's it right here.
Oh.
And then the y-intercept. So I didn't have to make the equation of that line. Cool. You said 3? All right. So number 3, it says f of x, which is a fancy way of saying y. -2 x minus 1 quantity squared plus 2. Okay, so what form is this in? Is it in standard form, ax squared plus bx plus c? Is it in factored form where I have a and then x a quantity and x a quantity? Or is it in vertex form?
Second one.
This is in vertex form. So if it's in vertex form, it's going to be opposite that, same that. Is that okay so far? Okay, and what does it say? So we want to find the vertex. Oh, we got the vertex. 1, 2. So 1, 2 is right here. Is that okay? What else do they ask for? Oh, axis of symmetry. So AOS is x equals 1. Okay. And then I don't know if I have any roots yet, and I don't know if the y-intercept is yet. So we're going to hold off on roots for right now. And then y-intercept we're going to hold off on as well. Maybe my pattern graphing will show it. So will this parabola open up or down? Down. Why do you say down? There's a negative out in front. That a value is a negative. And is it going to pattern graph at 135? No, it's going to double that. Okay? So it's a times 135. My a value I know is -2. So that's going to give me -2, -6, -10. And we normally don't use the very last one ever. All right, so I'm going to go right 1 down 2. Left 1 down 2. What did we just find on this one? I found the y-intercept and also roots. Okay, so I have roots. I have a root at 2, 0. And I have another root at 0, 0. I have a y-intercept that's also at 0, 0. Okay, so it's okay that a root and the y-intercept are the same. And then let's see, I can go one more. So I'm going to go right 1 down 6. Left 1 down 6. And we wind up with something like that. That's it. What other questions might you have come across on that one? Yeah?
5.
Number 5? Okay. Can I move off this one?
Yeah.
Sweet. Alright, number 5. We have okay. So, little trick on this one. It's in vertex form, and it's also in factored form. How's that? Well, let's explore this. If it's in vertex form, that means my vertex has to be -1, 0, which is right there. That is also my root. I have a singleton root. Okay? My axis of symmetry is x equals -1. And does this parabola open up or down? Up. Does it graph at 135 or at a different rate? 135 it'll work at because my A value on it happens to be 1. So I'm going to go right 1, left 1 up 1, and then right 1 up 3, left 1 up 3. John. Cool. Anything else? You have enough information? Yeah. Number 1. Number 1 is actually in standard form. Okay, number 1's in standard form. So that's f of x, fancy way to say y, x squared minus 4x plus 2. Okay? Okay, this is in standard form. So it doesn't present us the vertex real easily. It doesn't present us the roots real easy. I will tell you that I can get the y-intercept pretty easily up here because it's 0, 2. Because remember, the y-intercept is always 0, c. So I have an a value there, a b value there, a c value there. So right now, this is all I know. It's just a point. Okay? It's just the y-intercept in this case. All right, so question for you. How do we start finding the vertex if it's in standard form? What was that very first equation we started working with?
Negative b over 2a.
There you go, negative b over 2a. Cool. So I get x equals negative 4 over 2 times 1. Negative 4 is 4, so I got 4 over 2. So I got x equals 2. That's my axis of symmetry. Okay. My vertex, if I want to find my vertex, what do? Plug it in. So I'm going to plug that 2 in for x here and here. So I get 4 because 2 squared minus 8 plus 2. 4 minus 8 is negative 4. Negative 4 plus 2 is negative 2. So 2, negative 2 is right here. It pattern graphs as the 1, 3, 5. Agree? Because my a value is 1. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. Oh, look what I found again. Y-intercept again. It does indeed cross the x-axis, but my roots I can't see exactly. Okay, so if it didn't cross the x-axis, we call them complex. If we can't identify what they are right away, they are called irrational roots for the most part. Irrational means that it was like the square root of a number where it crosses, or some decimal that goes on and on and on forever. Okay? And when I say square root of a number, I'm like saying square root 7, where that's like 2-point non-repeating decimal forever. We good? All right, if you would, make sure your name is on that as well as anything else you might be handing in. And pass them over towards Mr. Boyd, and he will put them in the folder for us.
Es como él. Bueno, no es exacto, pero puedes entender que
Thank you, dude.
no, pues no.
Okay, a little shorter notes today. Little shorter notes. Everyone have a note sheet? Thank you, everyone. I'll wait for Jay to get back in because I don't want to start this without him. Hey, so can I tell you what our homecoming idea is for next year? You guys want to hear about it? So Dr. Keogh, who takes care of activities, said, "What do you think we should have?" And I said, I want to have it somehow saying taking care of one another. I said, okay. She goes, "What if we did something like this and we called it Imagine?" And then you start playing off Imagine this way. Imagine if every student here at Cherry Creek on the Monday brings in a can of food. Next thing, imagine if every kid at Cherry Creek High School brought in an old jacket to donate. On the Wednesday, imagine if all the kids at Cherry Creek High School brought in a new pair of socks to donate. And then just play it all the way off that we're obviously donating food, jackets, socks, and just keep going with whatever we can do with it. So, and then we could also play it off as, imagine if we made enough money at the homecoming dance that we don't just buy 95 gifts for the holidays at an elementary school, but we have enough to buy 2 full elementary schools for their kindergarten kids. Think about that.
Wait, a school? Like a whole entire school?
We buy it for all the kindergartners at Sable Elementary School. It was 95 kids. Sable Elementary School is this elementary school that is up on 225 in Colfax, on the opposite side of the highway from the Children's Hospital. They have 65 spoken languages that are at that school. They have a poverty rate where almost 100% of their population is on free and reduced lunch as well as free and reduced breakfast. And they also give their kids 2 bags of lunch to take home over the weekend. That's how poor they are. So because of the money we make from the homecoming dance with the Excalibur Club, we are able to purchase and dress up as Santa Claus. We spend between $20 and $30 per kid, and they have a wish list of what they want. Do some kids put, if they want a PS2? Yeah, we're not going to buy that. But some kids
get one for.
Huh?
You can get one for $30.
Oh, really?
Yeah, like Craigslist.
Craigslist. Well, we go over to Target over on Parker Road in Arapahoe, and we go spend about $3,000 on toys. So it's kind of a heads up opportunity. I think I'm excited about it. It should be good. All right. We are starting something that it's done the exact same way all the time. If you follow through how we do it every time, you're going to get the answer every time. Okay? And all it really is you are going to learn how to go from standard form, y equals ax squared plus b, or plus b plus. So you're going to go from this. So that's standard form. And we're going to take it and make it into vertex form. Okay? And again, it's going to be the same questions I ask over and over. And I know you can do it. You ready? So I'm going to look at the first question is y equals x squared plus 8x plus 16. Okay? So I want to make that into vertex form. So let me ask you this question. What's my a value right now? 1. If my a value is 1, that's fine. If my a value is not 1, I have to divide all 4 terms, including y, by whatever the a value is. So we'll see that eventually. All right, ready? So So step one is check if a value is 1. If not, then divide all by a value, including y. Okay? Good so far? So now we're ready for our next step. So if you sit and watch rather than write down, I'll give you time to write it all down in a second. Step 2. Make a space. Make a space. Well, here's make a space. Can you see the space I made? Pretty mathematical, isn't it? Made a space. Third step. Take half of b term and square it. Be sure to add and subtract from same side. Okay, now we're coming up on going on to daylight saving time this weekend, right? So what are we really doing with daylight saving time? We cut an hour off of the morning and we put it at the end of the day. So does the day change length at all? No. Native Americans state that only a fool would think they could take an hour off the beginning of the day and add it to the end of the day and act like they have a longer day. So we're fools. I don't like it. I grew up in Arizona. We didn't have it. But all right, so let's do this. Take half of b. What's my b value? 8. What's half of 8? 4. What's 4 squared? 4 squared. 4 squared. 16. So I'm going to go plus 16. And I'm going to go minus 16. Can you see how I just added it and subtracted it from the same side? Does that make sense? So this part right here, if I factored that, what would I get? What two numbers multiplied together to give me 16 and add together to give me 8? 4. So this right here technically is x plus 4 and x plus 4. I got to make sure I combine that together. What does that give me right there? 0. Oh, it worked out nicely. Do you agree with this? Then write it like this. If I do a quantity squared, does that mean the same thing as x plus 4 and x plus 4? So what's my vertex? Negative 4 and 0. Okay. Take time to write that down, and let's clarify any questions. While you're writing that down, I'm going to go get myself my banana. Whoa. Oh, sorry. I'm not that.
B to what?
Black, what color?
Black, the third.
Take half of B term and square it. Be sure to add and subtract it from the same side. Everyone had enough time to write down what you need? Oliver, good? Okay. I'm actually going to put this on a split screen right now. Where's my split screen? You know what? Because our thing ran out, we can't. Our subscription to this ran out, so we can't do it. All right, let's move to the next question. Actually, I'm going to move away from. The second one. I'm going to the third one. Okay. Ready? What's my A value? 4. It's not 1, is it? So I'm going to divide everything by 4. Do you agree with the math I did? If I go y divided by 4, or if I divide y by 4, I get y over 4. If I go 4x squared divided by 4, the 4's cancel. 20 divided by 4 is 5. And then 25 divided by 4 is just 25 over 4. Yeah.
Okay, so if it's 25 over 4, would you leave it like that, or make it into like a...
I would leave it like that. Now, I know we hate fractions, but this is actually a friendly fraction problem. And you'll see as it transpires to the end how it works. Okay, ready? What was the next step that we had made? The major dramatic step? Make a space. That's it. Make a space. Are you kidding me? I make a space? It's not math. What was my next step? What was my next step?
Take half of B,
Half of B,
term and
square it, and
add 2 and subtract them.
add and subtract from the same side. Okay, now this is where we're going to be friendly with fractions. If I want to take half of 5, I divide by 2. So 5 over 2 is half of 5. Leave it like that, though. Does that make sense so far? So let's do this. Ready? So this sign comes straight down. Good so far? Half of 5, I just said was 5 over 2. And then square it. What's 5 over 2 times 5 over 2 as a fraction? What's 5 times 5? 5 times 5. 2 times 2. 4. So this right here is this right here. If I took x plus 5 and x plus 5 and I FOILed it out, I get x squared plus 5x plus 25 fourths. Oh, look what happened here. What happens here? Yeah, I get a 0. So that's my completed square. We have one last thing to deal with. Remember when we divided everything by 4? We have to remember to multiply. So the only thing different on this step is multiply all 3 terms by 4. Okay, I'm going to highlight the terms. This is a term. Is that okay so far? This whole thing right here is another term. And this is also a term. You see all three terms up there? All right. Let's see if we can figure this out. Okay. If I multiply this by 4, this by 4, and this by 4, that cancels. I got y back. I got 4 times this quantity. Ooh. What is my vertex?
-5/2.
Negative 5/2 and 0. Done. Don't run away from the fractions. Don't run away from them. Does anyone need me to go up? Okay. All right, I want to go to the back side and just do the very top box. Do I have time to do it? Can I go off the screen? So I'm on the opposite side. Okay. What's my A value? 2. So what am I going to divide everything by? 2. So even the y gets divided. The 2/2 becomes just x squared. If I divide that by 2, I get minus 6x. Divide that by 2, I'm going to leave it as a fraction. That okay so far? The big mathematical idea we've come up with so far today is make a space. Yeah. We good so far? Now here's the great thing about this. Ready? This sign comes down. What's half of 6? 3. So I take half of that. I get 3. What's 3 squared? 9. If I add 9, I also subtract it. Look at that. I didn't even have to do any math. It's done. Like half of that right there. Every time. All day long. Okay. So let's take that 13/2 minus 9. Well, let's put 9/1. Should we do my fancy way of doing it? Subtract a fraction. So I get 13 minus 18 over 2. 13 minus 18 is -5 over 2. So that comes out to -5 over 2. I have 3 terms left, yes? What do I multiply all 3 terms by to get y all by itself? 2. Multiply that by a 2, that by a 2, and multiply that by a 2. That cancels to quantity x minus 3 squared. That cancels. Oh, look how nice that canceled. Hey, what's my vertex? Close. 3 common -5. There you go. That's done the exact same way. Okay? It's a little different thought process, yes? Is it impossible to do? Take your time. So let's do this. Will you do this for me? No? Okay. Page 81 and 82. The nice thing is 82 is blank.
Hey,
Why don't you just do the odds?
hey.
So if you get stuck on this, my friends, if you get stuck on this, at the very bottom of page 81 is a HTTPS on YouTube. It is the odd answers. So you can watch the video if you get stuck and it'll walk you through it. Okay? Sorry, you have to see me later tonight, but that's what we got. Dude, you guys nailed it.